This is Chapter 19, Unfamiliar Functions, and today we're going to talk about the properties of functions. For the most part, in real situations, you don't get easy graphs that model what's happening. But we can use some key features of the graphs that we get in order to identify what's going on in the function. So luckily we have graphing calculators that do most of the work for us, but there still are some specific things that we want to identify. So I've provided us with a little picture here. The first thing you want to identify are your intercepts. So here is the y-intercept, and the y-intercept is found by plugging in 0 for x and then getting a value for y. We also have some x-intercepts here, here, and here. And these are found by plugging in 0 for y and figuring out what the x value is. The y-intercept is very easy to calculate in a function. The x-intercept can be a little bit more difficult, so we often use our calculator in order to figure that out. And I'll show you how to do that in a minute. The x-intercepts are also sometimes called the zeros, and that's because it's where the y equals 0. It's where the function equals 0 when you solve for it. Next, we want to find turning points. Turning points are also called max and min. So up here, there would be a turning point. And this would be a local max, because if you look at the graph in that area, it's a maximum. Here is another turning point, and this would be called a local min, because in that place it's a turning point. And when we get into calculus, we'll be able to find these by finding the tangent of the curve and the derivative of the curve. But for right now, we're still just going to use our calculators. You also might need to find endpoints depending on the question. So this would be an endpoint, and this would be an endpoint. And you'll know because they'll give you a specific domain, and the endpoints are the range that correspond with that domain. Other things that you need to find are the domain and range, and values where the graph doesn't exist, so if there are any holes, and then also asymptotes. And we've talked about asymptotes a little bit already. Okay, so let's do an example, and we'll bring up the calculator and work through it. Alright, so I've got the calculator ready to go, and here is our first example. We are going to graph the function y equals 2x cubed minus 17x squared plus 42x minus 30. So let's go into the y equals, and we're going to type that all in. 2x cubed minus 17x squared plus 42x minus 30. Alright, now I'm going to set my window. I'm going to make my window pretty big because I don't really know what this looks like. So I'm going to go from negative 100 to 100, and I'm going to count by tens. And for the y's, I'm going to go from negative 100 to 100, also counting by tens. And graph. Okay, so there's my curve. Clearly I don't need to be as wide as I am, so I'm going to set my window again, making my x's a little more narrow. Since I'm counting by hundreds, basically I could go from probably like negative 20 to maybe positive 20, and that should probably give me everything that I need. So just zooming in a bit, just so that I can see a little bit more clearly, because I'm going to have to determine all those things that I talked about on the previous screen. Let's count by 2's in this case, and graph it again. Okay, so that's better. So there's another feature that you can use. It's called zoom and box. That's Z1. And basically what you do is you put your cursor as if it were at the corner, top corner of a box that you want to make. Once my cursor's in that spot, I'm going to hit enter, and then I drag to the right, and you can see I'm basically drawing a box, and then I drag down and it makes the box even bigger. And I want to make sure that I get the graph as it crosses the y-axis, so I'm going to go pretty far down, and then I can hit enter, and now I get my graph. Okay, so this is a lot better for me because I can see here's the y-intercept, here's one x-intercept, another x-intercept, and another x-intercept. Okay, we're going to have a turning point here, and that would be a local max, a turning point here, and that would be a local min. So now we're going to go through and figure out how to find all of that stuff. Alright, so the first thing that we are going to find is going to be our y-intercept. Remember that the y-intercept just means that you plug in 0 for x. So if I do that in this function, I'm going to get 0 minus 0 plus 0 minus 30. So my y-intercept equals negative 30. So the coordinates were 0 and negative 30. Okay? Now let's find the x-intercepts. In order to find the x-intercepts, we're going to use our calculator. Again, we don't use the trace feature because it's not specific enough. We're going to use a feature called zeros, just like we did when we were trying to find the intersection for solving exponential equations. Here we're going to do second calc, and this time we're going to choose number 2, which is 0. And what I have to do is I have to move my cursor so that it is just left of where I think the intersection is, and I'll hit enter, and then move it so that it's just right of where the intersection is, and I hit enter, and then it asks me to guess again, and if I want I can move the intersection or the point closer to it, but it doesn't really matter. Hit enter, and then it tells you the zeros. So my first 0 is 1.27. Alright, and then I have to repeat that process 2 more times for this graph. So I'll move over, I'll do second calc, choose number 2, left bound, enter, right bound, enter, somewhere in the middle, enter, and my 0 is 2.5. Alright, and then we do it a third time. Second, calc, 2, scroll over to left bound, enter, right bound, enter, my guess, enter, and my second coordinate, or my third 0 is 4.73. Now notice, on this one, when I look at my calculator, it doesn't tell me that y equals 0, but it does tell me that y equals negative 1 times 10 to the negative 11th, which is essentially 0. So as long as this number is super, super, super small, you can be pretty safe. You can bet on this number as being your actual 0. Okay, so we've got our y-intercepts, we've got our zeros, and these are all points. So these are all the points: 1.27, comma 0, 2.5, comma 0, and 4.73, comma 0. All right, so we got y-intercepts and x-intercepts. Now we're going to find the turning points. And let's start with our local max. And again, we're going to use the calc feature. So if I want, I can go ahead and I can move my cursor closer to basically this like little hump here. But we use second, calc, and now is this a max or a min? Well, this was a maximum, so we're going to choose number 4 for maximum. And then I'm going to move my cursor closer. And it's going to ask me the same questions that it did for the previous examples. So left bound. So you want to be slightly left of where you think the maximum is. Then it asks for right bound, slightly right of where the maximum is, and you hit enter. It asks you to guess, so put your cursor kind of where you think the maximum is, and then you hit enter. And then it gives you the coordinates. So our local max is given by these coordinates here. 1.82 and 2.19, rounding everything to 3 significant figures. Alright, so that was our local max. Now we're going to do it again, and we're going to find the local min. Again, we use second, calc, and we're going to choose this time the minimum, which is 3. And again, it asks us the same question, so we want to be slightly left of where we think the minimum is, and then slightly right of where we think the minimum is, and then directly in the middle where we think the minimum is, and then the calculator figured it out for us. So our local minimum in this case is 3.85 and negative 6.15. Alright? The next question we want to ask ourselves is about the domain and range. And in this case, remember, domain is how wide the graph is, it's the x values, and range is how tall the graph is, it's the y values. If we zoomed out to our original graph, were there any holes or gaps or anything like that? And the answer to that was no. And as we look at the equation, when we look at our basic equation up here, are there any reasons that I should restrict any values? Like, if I put any number in there, will it cause us to find an undefined value or something like that? And the answer is no, because it's just a polynomial. So in this case, our domain is going to be all real numbers, and our range is going to be all real numbers. So I get that in 2 ways. One, by looking at the graph, there weren't any asymptotes or holes. And 2, by looking at the equation, recognizing that it's just a polynomial equation. All right. Thirdly, next we want to check to see if there are asymptotes. And in this case, there are none. And then the 5th thing they would do is that we would sketch this graph and we would include all of these points. So we would include the y-intercept, our zeros, our local max, and our local min. All right? And then we would just sketch it. Okay, cool. So that's how you look at unfamiliar functions.